Okay, now just to put a bit of context as to what we're looking at in terms of transformations earlier in the week, basically what we're going to do is we're going to have a look at all of these different functions, or different equations, and compare them to y equals x squared. So based on what we did, what we're asking for is what do the effects of these different numbers do? Now, you should already know this, but just in case, we're going to go through it here. So, if we've got a coefficient of x, so we've got a 5 there, is that going to be wider or narrower than x squared? Well, it's a number, it's greater than 1, so this will be narrower. And it's dilated by a factor of 5 from x axis. So because it gets narrower, it's moving away from the x-axis. So I say it's dilated by a factor of 5 from the x-axis. Over here, we've got 2 over 5. Now, that's a number that's less than 1. So as a result, it's going to get wider. And we can also say that it's 2 over 5 units from the x-axis. X squared plus 3. So that's a standard x squared graph, but it's moved up 3. Now, we're expecting that you can be able to do this just by looking at it, just by recognizing, just by reading the equation. So it's important that you can do this. So if we add or subtract something, that's what it moves up or down by. So here, it's x squared minus 7, so it's going to move down by 7. This thing here, if we've got x minus 1 all squared, that gets moved to the right by 1. So if this is negative, it's moved to the right. If it's positive, it gets moved to the left. Having a look at the next one, x squared plus 10, x plus 10 all squared, well, that moves to the left, and it does that 10 units. So that's how all of these different types of transformations, that's the effect they have on them. We don't have to draw them every time, because the idea is that once you see it, you'll know exactly what it's doing to y equals x squared.